enough for everybody. I kind of want them here now.
Go, you're on.
It's time to go ahead.
Start your clock.
Good afternoon, everybody. My name is Marie Goheen, and I'd like to welcome you to the final presentation of the culmination of our senior year and pretty much our entire academic course at Central Washington University. And this is our final presentation, so I would like to thank you all for being here. My project, unless you live under a rock, you probably know that renewable energy has been a hot topic lately. It's everywhere, in the media, presidential debates, all over the place. So it's not surprising that our good folks at Central Washington University Rec Center down the way here asked for a functional display of sustainable exercise equipment for their facility. A similar project was done last year where we turned a red bike back there into a converting station where it could charge some small devices as well. So the plan was for me to use the bits and pieces off of that, and then my project was going to focus on just the attachment piece made to the bike. Some of the requirements that they had for the bicycle was that it didn't make any permanent changes to the bike and that it would be able to charge a small device. So the first thing that needed to be done was in the planning phase. I needed to come up with a way that to get the energy converted from the bike over to the pulley, and which would turn the generator to charge the devices. So these three designs were all considered originally. The first one had a generator that was attached by a belt, or the pulley was attached by a belt that went to the bike wheel here, and here's a small pulley that would be attached to the generator, and it was all driven by a belt. I couldn't figure out how to get that one to work without making some sort of permanent change to the bike wheel so the belt wouldn't slip off. So that one was discarded. The second idea was a sort of brake system here, where on your speed or wherever you have the brakes, and instead of the brake pads, it would have two pulleys on either side. One of the pulleys would be attached to the generator. The problem with that one is I couldn't really figure out how to attach the generator to the pulley, and there were kind of a lot of bits and pieces to it, so it was sort of a lot more complicated than the other designs. This third one had the pulley directly against the bike wheel, so the pulley would provide the pulley would turn the generator somehow, but it would have friction against the bike wheel there. So before disassembling the parts on the red bike, the generator was tested to determine that it needed to spin at 2100 RPM in order to generate 300 watts of electricity. So I did some testing and figured out that 60 RPM of the pedal was probably a good estimate for somebody who's not exercising too hard but still kind of getting a workout. So calculations were done determining the rate of the pedals to the rate of the wheel, and came out with 195 RPMs of the wheel. So using that number, I was able to calculate using this funny equation up here, and came up with a drive wheel that needed to be, or pulley or drive wheel, that needed to be 1.72 inches in order to generate the necessary 300 watts of electricity. The next step in the process was to figure out how to hold the drive wheel up against the bike. So I got to play with some machining parts and do all that fun stuff. And this configuration that you see up in the corner, which is not quite complete in that picture, but that's the general idea of it. That was the kind of the first generation of design. And I finished it up, got on, tested it, and this is what happened. Pay attention to this little pulley here. See it kind of sliding off there. Hopefully you were able to tell the belt that goes on the outside of the pulley is sliding off. And what you didn't get to see, because I didn't have enough time to get up to speed in the picture, was that it also jumped around a lot. The whole system was jumping up and down, and that was not good. So we kind of moved things around a little bit, and I came up with the final system that you see here. I pulled the shaft in toward the hinges and toward the bike wheel and moved the generator to the outside. And as you notice on this one, the generator kind of hung over the edge, and it was really heavy, caused a lot of torque on that. So I turned the generator around so the weight was more central and brought it out towards the edge, hoping that that would kind of help the balance simmer down a little bit. And this is what happened when I got on and tried it next. So you can see that bounce is still there. Depending on the speed, it would go away and come back. So you have to be at a certain speed to create the resonance necessary for the bouncing. And once you get up to exercising pace, it kind of goes away, but it's still not a good thing to have. So kind of went through a lot of machining and a lot of different techniques. I bent like 6 or 7 shafts trying to put them into the pulley because they were press fit into the pulley. I tried sanding the outer belt here, you can see, all sorts of stuff, and nothing really worked. Nothing would help get the pulley out until finally I was able to get a straight shaft in, and this took lots of trying. Able to get a straight shaft in there, and then I put it on the lathe and turned it down so that the outer, the band part, I was able to turn that down, and I got it perfect so that it was working beautifully. It wasn't exactly perfect. It still had a little bit of waver to it, but it was way smoother than anything else. And I finally was able to test and get some numbers, which I was happy with. So when I began testing, this was Tuesday of this week. I was supposed to have my testing done weeks ago, but due to all the pre-testing and trying to get the balance out, it didn't quite happen as I expected it to. So when I finally got my results here, it looked like this graph that you see up here. I measured volts and amps because the voltmeter that I had wasn't getting it up. The display on it was really too shaky for as fast as I was pedaling. It was really hard to read anything. So I ended up coming back and testing the volts and amps, and then I multiplied those together to get the watts. So if you can see here, remember I told you earlier that we were hoping for about 300 watts generated. As you can see, my chart goes up to 20. So I didn't come anywhere close to the results that I was hoping for. So in short, I did not fulfill any of the requirements of my project, but I did learn a lot. Mostly that if you don't know what you're doing, it's hard to know what to do. And also, I learned that machining accuracy is a lot more important than I thought originally. And My project took a lot more time than I expected, and as Professor Pringle always says, I'm on task. That's a good thing. Even if you don't know what you're doing, it's still good to go ahead and at least try to get there. So, in retrospect, if I had more time, I would have played around a lot more with the generator and tried to get it to a proper, at least some sort of numbers on it so that it was a lot more, so at least I had something to work with. Also, I would have done more testing. I do more gear ratios so that I can come up with proper ratios, and probably just change that around on the pulleys for the timing belt that actually drive the generator. And I kind of got really discouraged because I didn't fulfill any of the requirements. It's hard not to, but I would like to thank Eric for being very supportive and giving me the opportunity to do this. So thank you very much. And are there any questions?